Hello everyone and welcome back to theCUBE's live coverage of the Snowflake Summit here in San Francisco, California. I'm your host, Rebecca Knight, alongside Dave Vellante. I would like to welcome our next guest to the show. They are Spiros Xanthos, founder and CEO of Resolve AI, welcome.
Thank you.
And Dwarak Rajagopal, VP of AI Engineering and Research at Snowflake. Thank you so much for coming on the show.
Great to be here, thank you.
Yeah, we're excited to have you. So Spiros, I want to talk to you first. Tell our viewers a little bit about Resolve AI and what was the problem you saw that needed to be solved.
Yeah. So Resolve AI is building agents and models that can help you debug and run production software systems. The simplest way to think about us is we're the counterpart of coding agents for when software gets deployed and they become the defense, right? Our agents are on call, they can pick up any problem, whether it comes from a customer or an automated alert, debug it, get the root cause analysis and what the solution should be. So that helps accelerate the time it takes to resolve issues, it creates productivity gains, and also relieves humans from this very stressful task. When something goes wrong, especially in the middle of the night, you have to resolve it before it impacts customers. So that's roughly what Resolve is, right? And to build this technology, of course, we have to build agents, but also now we're training our own models, and this is the partnership we have with Snowflake.
Does Resolve AI, like somebody writes code and then is one of the use cases you're checking the code, testing the code, or not necessarily?
I mean, there is some overlap in the middle, right? When the code is about to be deployed, but the primary use case for Resolve is after the code has been deployed and is running in production. So Resolve essentially can understands code and the application, understands infrastructure, it can use, let's say, AWS tools, it can use all the observability tools that you might have in place, like Datadog, Splunk, etc., right? So it's an agent that acts as a human engineer or a site reliability engineer in essentially managing and debugging your production systems.
So, a developer wrote the code with, say, CoWork or Coco, and then maybe it was tested with Codo or something like that. Then you come in,
yes,
because things change, right?
This has always been a problem, right? Traditionally, you always have to have humans who look after the production system in case something goes wrong, right? Why things go wrong? Because yes, it could be because of a code change, or because it might be something that changed in the infrastructure, or how users use the product. So this has always been a difficult problem, and engineers spend quite a bit of time in solving that. But now with AI and AI-generated code, it has become essential that we have AI as a defense, right? Because we produce a lot more code, and also I would say developers are probably a little less intimately familiar with the code that gets deployed, right? So Resolve essentially is the solution to essentially dealing with all of that, right? So an AI that helps you with production.
So should we think of it as an SRE agent?
Correct, it's an SRE agent.
Great, awesome. And so what is now the SRE, obviously, it frees her or him up to do other things.
Correct.
What have you seen in terms of their activities?
Yeah, first of all, delivering software reliably is the most important aspect of engineering, right? So there is a lot of value in ensuring that happens, right? It gives you confidence to move faster, to release code more frequently, etc. But then, I would say this is also the stressful part of the job, right? So if you can let's say, if you can reduce the number of people that need to be involved in this, then they can go back to building, right? They can go back to essentially creating business value, which is the most important thing.
Yeah, good. Okay, you said you're working with Snowflake to build models, train models. Tell us about that.
Yeah, so we are extending Cortex platform to actually train custom models in the safe, governed environment. And one of the things that what we hear from a lot of our customers is customized models, training customized models for their unique use cases, for their unique enterprise data is like super critical. And one of the things that what we are kind of making it easier for them to do is to basically enable them to just focus on that problem and not worry about infrastructure, not worry about distributed systems, not worry about GPU kind of sourcing, all of that, we handle it. And so makes it much more easier. They could now then start with like open weight models with like Qwen or Mistral, and then customize their model specifically for the use cases, and then train that. So that's one of the big things that we've been building over there.
Why would a customer, Dwarak, come to Snowflake to do that? Maybe I should ask Spiros. Why would you go to Snowflake to do that versus going to, say, an AI cloud, like a CoreWeave or a hyperscaler? Why Snowflake?
I think the key element is two things. One is the enterprise data. Customers want want to kind of train where the data is already there, and when you take the data out, you kind of lose some of the access control and all that stuff. So that's kind of one of the key elements. The other one is some of the things that what we are doing at scale in a governed way. So you could kind of enable training in a very safe way, but also you could kind of govern what data is accessible and not. So that is one of the key elements and differentiation for Snowflake.
Is that why you chose?
Yeah, all these are valid, and from our perspective, we're an AI company, right? Like the domain we're in is very broad and wide. It's a very hard domain also. Yeah. And I would say it is already, let's say, the state of the art with what you can do with, let's say, existing models. But what we found is to go beyond that, we have to actually start, investing in training our own models. And of course, we want to spend our time as much as possible on the problem itself, right? We don't want to build infrastructure for model training if this can come, right? And we found that Snowflake's, let's say, abstraction for model training, right? And the platform they're building is the ideal for what we're trying to do, right? So it lets us, scale, move quickly, but also focus on what's important to us, right? Not the building infrastructure for model training.
So you don't want the bare metal infrastructure. That abstraction layer means you can focus on your higher level work.
That abstraction layer has to exist. So whether we build it or work with a partner, it has to be there, right?
It has to be there.
In our case, this is not what we're going to differentiate on, right? So it's better to obviously given Snowflake provides us to us, it's a great win.
So Dwarak, your AI team built Cortex training. What was the customer problem that you kept hearing, and why was it so hard to get it right?
Right, so I think one of the key elements for AI training right now is especially on the reinforcement learning. How do you kind of do it in an optimized way, more efficient way? That's one of the big problems. The second one is, like Spiros mentioned, just the ability to kind of scale GPUs that what you want in an elastic way for your training, instead of customer needs to worry about actually, I need this many GPUs for this many months. You basically kind of have the ability to elastically scale. So those are kind of like the two big problems, and that's one of the key elements that we are solving this with the Cortex training side.
How are you dealing with every earnings call I hear, we're supply constrained, we're supply constrained. I guess that's not necessarily your problem, but it sort of is a second order effect. How are you dealing with that?
Definitely, I think like inference compute as well as training compute is kind of like a big currency right now. One of the things what our technology allows is to actually do some multi-tenant across different workloads within the same GPUs. So we could actually do much more efficiently and also give those kind of savings back to our customers as well. So that's one of the things that we've been like spending time to kind of increase the efficiency for our systems as well.
So you're getting, does it have a utilization impact as well?
Exactly. So we kind of dramatically improve the utilization through some of the technologies that we built recently. For example, Zoro, which is a zero redundancy rollouts specifically for oral training. So things like that, we kind of mix a combination of these techniques to kind of improve the efficiencies.
I hear a wide spectrum. The neoclouds tell me they get 90% plus utilization, and I talk to the enterprise folks and they're like, we're still trying to figure out how to use this stuff. What are you finding?
I think it really depends on the benchmark and the use cases that you kind of want to use, and especially for like very domain-specific custom training, I think utilization is something that is super critical for our customer to actually kind of scale pretty well with better efficiency overall.
So one of the big debates we're having in our community right now is there's a camp that says the frontier model vendors, they're going to own everything. They're going to just gobble up, and these small, highly specialized models are going to go away. The other camp says, no. The small specialized models are just that. It's like specialized models. They're going to be much more efficient, much more cost effective, and more nimble. I know where you land, but defend your smaller model position.
So, I mean, it's not about the size of the model, by the way, right? Because usually, especially when you're doing post-training, you can start with an open weight model, could be quite large, right? And I think maybe the debate even starts there, right? What is our belief? Is our belief that open source models are going to actually evolve at the same pace and be as good or close to as good as the closed models in the long term? If we believe that, then it's easy from there to also, extrapolate that, training specialized models, right, is also going to be something that's meaningful, because if you have data that's specific to your domain, you can do a better job. Now, also I would say philosophically, I don't believe like it's easy to be the power plant and supply all the devices as well on top of it, right? And I think that, because there is deep expertise in every domain, right? And we see this with ourselves. I don't believe the labs possess that expertise. Obviously, we have great models, but I think at some point, these domains are so deep, and the end user wants a solution, right? They don't just want, let's say, a model to build on. So in that sense, I do believe that providing solutions makes sense, and for those solutions to be, let's say, the state of the art, it probably makes sense to have at least part of them served with custom models that you post-train for the domain.
So what are the domains that you're going after?
So in our case, it's production, right? So obviously, we have seen that the models have evolved amazingly well in terms of coding, but production is a very different part, right? Yes, you still have code, but then you have many, many other tools. And the reasoning steps a human takes to solve a problem or to perform a task usually are very, very long. Also, production is very noisy. The data is practically infinite, right? It doesn't fit in the context windows. So I think if you can manage to have models that do that reasoning better for this particular domain, you can have actually a big win compared to what frontier models can do.
Can you give us a sense of that win, and just in terms of latency or other business value that you're seeing?
So I think it comes down to two questions, right? Can you have state-of-the-art quality, right? Outcome reasoning. And that is kind of the big bet. But actually that matters, let's say, for the hardest problems. The other thing that matters a lot, what is the performance to price ratio, right? And I would say for that, you can definitely do better than the frontier models by having your own custom models for many, many of the tasks that you're going to perform in production. And we already see the token maxing probably is coming to an end, right? And people are going to rationalize the investment. So in that world, I do think it matters to have a model that is great, but it's also more efficient for the problem you're solving.
The other debate that we have a lot, I'd love to pick your brains on this, is people say, well, you don't need the latest and greatest models. The other side of the camp says, well, the latest and greatest model is going to have the best price per token, the most efficient operations. I hear this all the time, that spectrum. I know it's an it depends answer, but what are you seeing out in the field?
I think the way from our experience, what we see is that I think there is space for both, for sure. I see models as a way where intelligence is compressed within a model. Usually, if you think about it, in a frontier model, the amount of compression it needs to put it in versus if you want to have a very specific business use case where you could do a better compression with a domain-specific model. And so in that case, you could have both not just the speed and latency, but also actually accuracy in terms of how you kind of get to that. So for a more generic kind of use cases, frontier models are generally the best use case, best answers. But if you want to have very specific kind of what Resolve is working on, that actually has a very good kind of product market fit for a customized model to come and actually help.
And maybe I can give you a different perspective from how Resolve approaches this, right? Slightly different, not I agree basically with what you said, but at the end of the day, Resolve delivers a certain solution, right? We have many, many agents that work together. Those agents are backed by different models. So even for the same task, you might have a frontier model, which is ideal for part of the tasks, and maybe you have other models, sometimes custom models, or sometimes actually a model from a different provider. So at the end of the day, you're thinking of a solution, right? You're not thinking of is A or B, right? Typically, it's both of them working together in some formation.
So how do you use the frontier models? How do you use them all? Do you have a sort of model chooser?
Yeah, we actually use pretty much, at least from the three big providers, models. And oftentimes, because in the domain we're in, right, which problems are really hard to solve, sometimes we have agents have an adversarial approach with each other, right? When an agent makes a claim, we'll try to have another agent verify that, right? And even using different models to back these two agents oftentimes helps with quality in the outcomes, right? So typically, generally speaking, the models we use change all the time. We run evaluations every night, and it might change from day to day, right? And every time a new model drops, the configuration probably changes, right? So that's the other part of building a sophisticated AI solution. It's not just about the model, right? It's how do you evaluate the models? When something doesn't work, what do you do about it, right? And that's, again, maybe where custom model training comes into play, because when you have gathered all this data and you know what works and what doesn't, you can probably produce something that works more effectively.
So it's interesting, Rebecca, we're talking about training. People typically don't want to talk about training today, they just want to talk about inference, training is expensive. That was yesterday's news. Now the news is all around inference, but what you just described, changes in the field, that requires inference. So explain sort of how you go for trainings, like they say, well, you're in college, and in inference is when you actually go to work. So when you go to work, what is that transition like? How do you work with Snowflake in that regard?
That's a good point. So actually we're collaborating with Snowflake on inference as well, right? And inference in our case could be running our own models, let's say, right? Running inference on our own models, but it's also frontier models. essentially using an API, right? Whether it's an Anthropic API or an endpoint, whether it's on Snowflake or directly on Anthropic and OpenAI, right? But yeah, we're partnering with Snowflake on that as well, right? And obviously, the closer, let's say, all your models are in one place, the more beneficial it is, at the end.
And how do I transact business with Resolve AI?
So Resolve, essentially, we're not selling software. We're doing work, right? We're selling an outcome. So the way Resolve works is that you can think of us as, you can use the agents to do let's say, to be on call, to do root cause analysis of production incidents, or to perform other tasks, necessary tasks that a human would otherwise have to do. So you buy basically credits, and then each one of these outcomes consumes a number of credits. If the agents do work, you get charged. If they're just sitting there, nothing happens, right? This is not a software subscription.
And you predict or forecast or propose up front what my outcome is going to cost?
Yes.
And then if there's a change order, there's a change order.
At least for the use case of, let's say, incidents and on-call, typically you know how many of those you have in a typical month, right? So it's not that difficult to estimate how many you're going to need. Of course, as then the agents get deployed for more use cases, some of these use cases are less easy to predict. But then we provide daily, let's say, reports and analytics, so it's easy to extrapolate also.
And you're essentially, your economics are a function of token costs, right? And obviously you're humans, and then you add value on top of that.
Correct.
And it's got to be less expensive than humans doing it on the other side.
It is quite a bit less expensive. Yeah. But also I think the problem we're dealing with is very, very hard, and it's important, right? Delivering software reliably, especially for those who deliver their business through software, is the most important part of actually software, right? So if you solve this problem well, obviously you create a lot of economic value, right? That allows you to both spend on R&D, spend on inference, but also still have a very healthy margin.
It's a quality play as much as it is a cost play, yeah, excellent.
So where do we go from here with everything that Cortex training has enabled now? What do you see as the future?
I think one of the key element here is what Spiros was saying is a combination of both using frontier models as well as the custom models as a solution is going to be more and more kind of abstracted away from the users, that some of these things would be handled across the things. And one of the key elements on the infrastructure challenges for training, we talked about inference being the hot thing, but not training is coming back in some sense, but a lot of the infrastructural challenges for training are actually related to inference. For example, Oral actually requires a lot of inference happening at the rollout. So they are kind of interrelated in terms of how the systems are actually being built. And so we do see kind of both inference and training kind of coming closer together the way the systems are being built as well.
Excellent. Well, Dwarak and Spiros, thank you both so much for coming on the show. A really interesting conversation.
Thank you, yeah.
Thank you.
I'm Rebecca Knight for Dave Vellante. Stay tuned for more of theCUBE's live coverage of the Snowflake Summit. You're watching theCUBE, the leader in enterprise tech news and analysis.